dimensions form also another advantage is it is actually no dimension is it is material invariant. That means if you have different parameters like volumetric K modulus and other parameters. So in that case, if you have different kind of limits, say high K modulus, low K modulus, in that case, from dimensionless analysis, we can have generalized characteristics, and that will be valid for any chemical reaction. Because what actually, if you give any chemical reaction, and based on the parameters like rate constant and other things, you can actually calculate the phi. That means for different values of phi, you get the characteristics A bar versus Z bar. In that case, that will be valid for any chemical reaction. So not only for the implementation part was for the finite difference method, but it actually gives the material value characteristics. So we will discuss now how to implement finite difference method for this type of problems. And we have done already forward difference, backward difference, central difference. So now we will actually look into it. But yesterday actually I was asking you to do the alpha 0, alpha 1, the boundary condition. Have you got it? So the problem actually we discussed yesterday. The dimensionless form d2 Ca bar by dz square bar square minus beta Ca bar to the power n equals to 0. That's the governing equation. Okay. And beta we have seen that the dimensionless, which is called as volumetric K modulus. Boundary conditions at z equals to 0, we have Ca bar equals to at z equals to 1 dCA bar by dz bar plus alpha 0 Ca bar equals to alpha 1. We got the values of alpha 0 alpha 1, right? You can actually get it from the parameters. Okay. So if we implement finite difference method, we will implement finite because this type of problem you may not get an ideal solution. Okay, for this case you can get an ideal solution, right? Can you get an ideal solution for this case? Yes or no? You may not be, right? Your Ca bar to the power n is there. You may not be. You won't get it. And sometimes what actually happens, you have Langmuir-Institute kinetics. That means A is going to B. It is not a simple step. Now it becomes A equals to A star going to B star, and B star going to B. Three-step kinetics. This kind of kinetics you have seen. And for this kind of kinetics, actually it is not Kc or Kc to the power, it's K by 1 plus K, something like that. This kind of kinetics, that will make this system very complicated. That will make this system very complicated. Okay, so for those complicated systems, you won't get an ideal solution, and we have to use the finite difference method. And remember that we are talking about the pore diffusion for the catalysis, for not the catalysis, but for the chemical reaction in the mass diffusion. So if we use the finite difference method, what kind of system we will get from this entire thing? Any idea? We have discussed already. If you use finite difference method, what we will get finally? This we have a differential, we have ordinary differential equation and the boundary condition, the steady state. Set of excellent, set of algebraic, set of what, linear or non-linear? Linear, sure.
N plus power.
Is the equation linear or non-linear? Set of non-linear algebraic equations. Okay? Set of non-linear algebraic equations. You get set of non-linear algebraic equations. Okay. So how to implement the finite difference method? To take domain. Okay. So before the finite difference method, I will talk about something. So need to introduce the concept of. Need to introduce the concept residual Jacobian. Residual and Jacobian. What is residual Jacobian? So this actually comes from Newton-Raphson method.
For example, we want to solve an equation, say x square plus e to the power x equals to 0. And the solution is not possible. For this case, and the solution is not possible. So in that case, how to solve reduction method? You have x mu equals to x whole minus f of x whole by f prime x whole. This got the one equation. So now if I have set of equations like x square plus e to the power y equals to say some function say ax and y square plus e to the power x equals to say v1. Two equations here. How to solve it? This was single equation. This was single equation. If I have two nonlinear equations, how to solve it? Middle option method. How to constant Jacobi? How to extend this formula for vectors? I am saying now x will be a vector. So what we can actually say, x1 square plus e to the power x2 equals to ax1, x2 square plus e to the power ax1 equals to bx2. So you can write f1 x vector equals to 0, f2 x vector equals to 0. So in that case you can see f is also a vector and x is also a vector. F is also a vector. F is functions, two functions, vector. X is also vector. So how to extend this formula for this type of system? How did you get this formula? Can you derive from Taylor series? How can you derive from the Taylor series? I cannot do like this. You are showing like this. I can also do like this and go back, go to home. I can do like that. I can do like this, do like this, do like this. So many things I can do. I do drama in the class and push up. Then at the end you will say the teacher is very bad. I cannot tell my students are bad. Irreversible process. Yes, how to derive this formula from Taylor series? How did you get introduction method? I thought so many times. This is the initial guess. Do like this and finally get a solution. So if you type the Taylor series, that means f of x plus h equals to f of x plus h f prime x h square by 2 factorial f double prime x and so on. X plus h you can say that f of x nu equals to f of x whole plus x nu minus x whole, right? X plus h is minus x is h, right? X nu minus x whole. F prime will be what? F prime x of f of x whole, and there's a higher order term. And what actually happens? How do you get this one? If you look at the picture, it says what? I am saying my function is linear. So this is your x whole, and this is your x nu, and f of x nu equal to 0. That's what I am saying. So introduction method, I have a curved function, but I am saying a function is linear. With that I get a new guess. I draw tangent. And finally what actually happens? Some regime we can see function is linear. Okay? So that's why you will actually get convergence. So every point you can see that function is linear, it is cutting the x-axis, f of x equal to 0. So you have, and since linear, there will be no higher order term. Because of linearity, there is no higher order term. Because linear case, we can have only first derivative, there is no second derivative. For example, ax equals ax plus b, function of x equals to x plus b. So d of function of x by dx equals to a, and d2f by dx equals to 0. So in that case, what actually happens? X nu minus x whole equals to minus of f x whole divided by f prime x out. And that's the algorithm. Now my question is, if I extend this concept for the multiple variables, how the formula will be? That means if I have f of x1, x2, say xn, n variables. This I call new variable. New. How can you write the Taylor series? How can you write the Taylor series? Can you extend Taylor series from here? Of course, the first term will be what? F of x1 old, x2 old, xn old. Plus, for h means only one variable. So like that, there are so many variables, n variables. So first variable will be x1 new minus x1 old. Then instead of f prime, it will be dou f by dou x1. At x1 old, right? It is x1 old only. F prime x1 old. Have they extended? Similarly, x2 new minus x2 old, dou f by dou x2 old, and it will go on. I will not go higher order because linear approximation. So what you get? And this term will be 0, linear approximation. It will go to 0 like this, f of x new. So you have minus f of x vector old. I will not write down, I just write x vector. Right? I write x vector. The x vector has x1 old, x2 old, x3 old, xn old. Does x bar old vector. Okay. And then what you get? You will get x1 new minus x1 old, dou f dou x1 at x equals to x1 equals x1 old, and so on. So what you get finally? Minus f of x bar old. So like that we have vectors of delta x bar. So we can have delta x bar vector which are defined as x1 new minus x1, x2 new minus x2. We have xn new minus xn old. Right? Clear? So what will actually happen? How to write in terms of vector multiplication, vector multiplication. So like that, we have also f bar. So this will be extended. So this is actually asking for f1. Okay, this is dou f1. This I am just putting for dou f1. First function. Like that, you have second function also. So second function I will write for you. Then I will fill up the last line. So what will be my second function? f2 x1 new, or I can write fn, any finite function, xn new equals to fn x1 old, xn old plus x1 new, x1 old, dou fn, dou x1, x1 old, and so on. Okay? So if you look at this also goes to. Okay? So if you combine all these n equations, like that you get n equations. So you get left hand side vector, right? So if you combine all equations, left hand side will be having minus f bar, x bar old. Am I correct? What was vector? Right? So f1, so minus f1 x old, minus f2 x old, minus fn x old. You write in a vector format, you get minus f bar x old bar equals to. You have delta x bar, always will be there. This x1 new bar, x1 old bar. So you get a matrix, right? What is that matrix? I'll delete this one, so you can actually write a big matrix. What is that matrix? First equation is what? f1 x old bar equal to delta x bar. Delta x bar into what? Delta x bar means x1 new bar, new minus x1 old into dou f1 dou x1. Then next multiplication will be. So it should not be here. It will be actually here.
Otherwise you cannot, sorry, dou f1 dou x2 and we have dou f1 dou xn. So now if you look at, if you can multiply, you get vector, otherwise if you do it, it cannot be done. So it is n by n, it is n by 1, you get n by 1, here it is n by n. Others don't match, because if you put n by 1, you cannot multiply. Right? So, second equation will be dou f2 dou x1, dou f2 dou x2, dou f2 dou xn. Last equation is dou fn dou x1, dou fn dou x2, and dou fn dou xn. This is called as, this matrix is called as Jacobian matrix. This matrix is called as Jacobian matrix, and representing this f1 is called as residual. Generally speaking, when you have guesses, residual is not zero. Okay, if you give initial guess, and it cannot be zero because this is the error. This is the error, initial guess. But when it will convert, the solution will convert, residual is zero. Initial residual is not zero. First guess, you see that so much difference is there. Then you give another guess, difference is less. 1 point difference is zero. And this is basically called, so what actually happens that when you put the x cube value here, initially it won't be zero, it is having some value. So that is called residual. And what actually happens in Newton-Raphson method, if you, so residual, how to calculate converters? How to calculate converters? So if you look at, you have minus 8 bar equals to j delta bar, delta x, delta bar evaluated at x bar equals to x over 2. This is my equation. This is like ax equals to b. Okay? Unknown is delta x. What is that? x1 nu minus x1. If you know delta x1, you can convert x1 nu because x1 nu equals to x1 old plus delta x. Delta x1, x2 nu equals to x2 old plus delta x2, and so on. So similarly, x bar nu equals to x bar old plus delta x1. Right? Yeah. But thing is that how you do that? So you get from here x bar nu, and which will be assigned as x bar old, and then again do the same calculation. How long you do that? Thing is that you need to have convergence criteria. What is the convergence criteria? Convergence criteria is, so you have f1, f2, fn. These are my functions. Okay? So what actually happens, as I discussed, this is your exact solution, and this is the approximate solution, and this is the error. Right? So when the solution is exact, that means each of f1, f2, fn has to be zero. Each of that. That means how to ensure that each of f1? It is very difficult to calculate each of f1, f2 equals 0. So rather, it is possible to calculate the 2 norm, which is summation fi square over the corner. If it is less than equals to 0, that means you are ensuring that each are square term, remember that. And 0 means each must be very, very small. Otherwise, sum of the squares cannot be less than equal to 0. You cannot prove it. Because sum of the squares, any square term cannot be negative. This is dangerous. If it is coming negative, that means something wrong you are doing. It is not possible. You cannot do that. So, if this is less than equal to 0, that means you got a convergence. Then you say, okay, my x nu is my solution. That's the answer. That is the way overall convergence actually works. Any questions, doubts, confusion here for the Newton-Raphson method? How it works? Okay. So if you want to play with the Newton-Raphson method, maybe you can take up some of the problem I can pick it up. So everything is clear here, right? Newton-Raphson method for nonlinear system. X square plus y square plus xy
30. Can you solve by this technique? How to solve? So this is the way to understand this data technique. How to solve? What's the first step? What's the first step? First step is to assign a guess XOR. Assign a guess. How to give the guess? You can actually put like this, no problem. X plus y, I am putting complicated. I am making system complicated. X plus y square equals to 4. Why to put x plus y equals to 4? So you can give initial guess 1, 1. Okay? You can give initial guess as 1, 1. That's a good guess. What will be my procedure? You have to solve each equation like this. How to have? So it is like Ax equals to B, and F bar is what? F bar is actually at x equals to XO. You know that. At x equals to XO. So how to have F bar calculation? So my F, so this is my F1 equals to 0. It will be 0 exactly for the solution, otherwise it will be received. So that's why it will be 0. That's why you can calculate minus, that's otherwise it will always 0. So F bar is, if you calculate 1 plus 1, 2, plus 1, 3, minus 3 is minus 2. 1 plus 1, 2, minus 4, what is that? Minus 2. What is Jacobian matrix? Which is dou F1, dou X1, dou F1, dou X2, dou F2, dou X1, dou F2, dou X2. Evaluated at x bar equals to x bar over. J bar will be, what is dou F1, dou X1? You calculate it. Which is 2 of x. So actually what we have to do that, you define here, now x1 is x, x2 is y. So in that case it will be quite easy. Otherwise, always this is the way we write in the computer program. If you put in terms of y is a problem, because you cannot put a computer program for 1,000 variables. Okay, so dou f by dou x1 will be what? Yes. What is that? 2x1 plus x2. Dou f1 by dou x2, 2x2 plus dou f2 by dou x1, dou f1 by dou x2. Excellent. So now if you look at, it has one value. Initial 3, 3, 1, 2. 3, 3, 1, 2. Okay. Now you can do introduction method by hand. How to do that? 3, 3, 1, 2. Delta x1, delta x2 equals to minus 10 minus 2. You can have plus 10 plus 2. What's the solution? 2 by 2 system I am doing. Minimum, you cannot do 1 by 1 like this. 2 by 2. What's the answer? What is the answer? 2 by 2 only. I am not doing 3 by 3. Simple. You can do grammar school directly. Get the answer. For the grammar school, delta x1 will be 10, 2, 3, 2 divided by 3, 3, 1, 2. Delta x2 will be 3, 1, 10, 2 divided by 3, 3, 1, 2. If you don't know grammar school, because I am assuming you don't know anything of the maths code, because I am already a teacher. So at the end of the class, I assume that your level is still in 10 plus 2 or BTech first year. Except one or 2 days. Yeah. What is delta x1? What is delta x2? 14 by 3 and 14 by 3 minus. What is my new base then? X1 new will be X1 old plus delta X1. X1 old is 1 plus 14 by 3 which is 17 by 3. X2 new will be, what is that? Minus 1 by? Minus 1 by 3. 1 is going to 17 by 3 minus 1 by 3. So again what you do? You go back there. So one thing I can suggest that we can also start with 1 0. If you want to, but this is the way. So we can have different initial values. So x2 new, again you do the same process, calculate, and what is the summation? What is your not true norm? Here we can calculate true norm. What is true norm? At this point, what is true norm? 17 by 3 minus 1 by 3. You calculate f1, you calculate f2, do summation of square root, you can get some idea. What is the true norm? What is the true norm? What is true norm? .4 is very high. So similarly you can calculate the subsequent steps. So now how the convergence goes. So you have seen that you have learned the algorithm part. Even you can implement for n by n systems. Convergence criteria. When it goes to less than 1, that means you are going to in vicinity of the solution. When it goes to less than 1, say 10 to the power minus 1, if it is, next iteration minus 2, minus 2. This is called as quadratic convergence. What is that? Because if you take the square, you get this. If you take the square, you get this. And then it will be minus 8. So if you look at in the vicinity of the solution regime, it is quadratically converging. This convergence is very fast. It's called quadratic convergence. So that means if you are writing an algorithm, you are writing a program, and if your solution is not converging quadratically, solution is not converging quadratically, then you have some problem. Then you have some problem. What problem it could be? Could be your Jacobian is wrong or the algorithm is wrong. Could be your Jacobian is wrong, algorithm is wrong. So one can actually write a computer program for that in MATLAB, maybe some 10 lines computer program, and see that whether you understand the program correctly and whether you are getting quadratic convergence in the solutions. So that means when you develop interaction method code, if you get quadratic convergence, that means your scheme is correct and you must get the solution. So I think that much in knowledge is actually sufficient to perform the residual calculation for our code diffusion problem. You can do this problem, the whatever I did here, we can give initial case 3 and 0.5. Okay, solution is 3 and 1. Okay, 3 and 0.5 and see, I'm sure roughly within 2 or 3 iterations we will get the solution and give me on first. Okay. And I also wanted to have the solutions for, I think remember that for the finite point transform 2 problems I gave long back, ordinary differential equations, you didn't give me that one, we just gave it to you. Okay. How to perform the finite difference method here? This is my first node, second node, and nth node. The n nodes. What are the variables? CA bar 1, CA bar 2, and CA bar n.
In computer program, these are called as dimension variable. In computer program, these are called as dimension variable. And eventually what you have to do, whatever you have learned, you have to do in the computer program, because in these days, without computer program, nothing goes, because you have to work on 1,000 set of differential equations, 1,000 algebraic. So there are n variables. Okay? Each variable represents each node. And as I say, finite difference method, this differential equation should be written for each node, except the boundary domain, but the boundary conditions are specified. So, at the first node, at the node 1, what condition you have? CA bar equals to 1. That means CA bar minus 1 equals to 0, which is my first residual, and sometimes I call as R1 instead of F1. Since residual instead of F1 I call R1. So first node boundary condition is there, and that is Dirichlet condition. That's what Dirichlet condition means, which is based on, which is called as a strong condition. That means solution is given there. There is no point to write the differential equation. Solution is given here, so the condition is this. Node number 2, I will put node number I. Is better, because node number 2 is again you have to write enough node number I. For node number I, which will be valid for 2 to n minus 1. Node number I is valid for, so that means up to n minus 1, we can peacefully write the same thing in do loop. So in the computer program there is something called do loop. You have heard all those things, right? In MATLAB also you can do loop, do while or something. So 2 and 2 and 2, for ith node, what actually happens? We can write d2 CA bar dz bar square minus beta CA bar to the power n for the ith node equals to 0. Right? For the ith node, if we use the central difference formula, what formula we get? For this d2 CA bar by dz square we have already discussed. So the central difference formula. The central difference formula, what will you get? CA bar, what is that? I plus 1 plus or minus? Minus 2 CA bar. I minus 1 delta I put delta z. Say I write this way, I minus 1, I plus 1, I put here delta z, I put here delta z. Read length square minus beta CA bar of I whole to the power n equals to 0. Am I correct? Yes or no? So, my first residual in the computer dimension variable is CA bar 1 minus 1 equals to 0. My R2 will be, you can write this way, delta z square, beta delta z square you can write. Okay? So, what is my R2 then? From here, can you derive R2? CA bar 3 minus 2 CA bar 2 CA bar 1 minus beta delta z square CA bar of 1 2 all in the power n right? R3 will be CA bar 4 minus 2 CA bar 3 plus CA bar 2 minus beta delta z square CA bar 3. It will go R n minus 1, which is CA bar n minus 2 CA bar n. Sorry, n minus 1 plus CA bar. What is that? N minus 2 CA
CA bar n.
No, it will be n minus 1.
N minus 2. Correct only, right? Am I correct or wrong? Minus beta delta z square CA bar n minus 1 to the power n. What will happen at this point? Nth point. Nth point, you can see that the boundary condition is defined. Pardon? That is the condition. But if you implement the condition, what will happen? Let's see the fun here. Let's see the fun at the nth point. Shall I read this part? Now this is of no use. Only I think I can use this one. Other things I have told you can write. So I can work in this place. At nth node, d2 CA bar dz bar square alpha 0 CA bar minus alpha equals to 0 at nth node. At nth node, what will happen? Central difference formula. You can see that nothing is here. So you can define a superficial node n plus 1. We need a superficial node.
So the first term will be dCA by dz.
Oh, sorry. We need to have superficial node. Why? Because dC and dz is dy dx is yi plus 1 minus yi minus 1. So for this node, we need to have this node and this node. Right? But this is not there. Remember that. This is superficial. So this is called as superficial or false node. It is not there, false. That means you should not come in a calculation. Your domain is defined up to 1 point. The domain is not defined here. This is somewhere outside. So it is CA bar n plus 1 minus CA bar n plus alpha 0 delta z square CA bar of n minus alpha 1 equals to, am I correct? I wrote direct delta z, so alpha dot delta z square. Delta z? What is the formula? 2 delta z, right? 2 delta z, yeah. I don't remember the formula. 2 delta z, right? yi plus 1 minus yi by 2 delta z. What is that?
CA bar n minus 1.
Okay? So your Rn will be CA bar n plus 1 minus CA bar n minus 1 plus alpha 0 2 delta z CA bar n minus alpha 1 2 delta z equals to 0. And there is a problem because this is variable non-existent. You cannot have one extra variable. You have n algebraic equations and n are n unknowns, right? There are n unknowns and you got n algebraic equations. If unknown is n plus 1, you know the situation. Dangerous. We don't know. You want a unique solution. So this has to be eliminated. How to eliminate this one? We have differential equation d2CA by dz square. So we can write this equation for the nth node. What is that equation? The equation is CA bar n plus 1 minus 2 CA bar n plus CA bar n minus 1 beta delta z square CA bar of n to the power n equals to 0. Yes? From here, one can write CA bar n plus 1 equals to alpha 1 2 delta z minus alpha 0 2 delta z CA bar n plus CA bar n minus 1. From here, you can write this CA bar n plus 1 can be substituted here and you get the recipe. So it will be CA alpha 1 2 delta z minus alpha 0 2 delta z CA bar n plus CA bar n minus 1 minus 2 CA bar n plus CA bar n minus 1 minus beta delta z squared CA bar n equal to 0. So in that case, CA bar n plus 1 is not there. So now what I am asking that, what is my final form of R of n, last residual? What is my final form, the last residual? What's the final form of my last residual? My final form is, what is that? Minus 2 CA bar n. Am I correct? This will be replaced by something else. This is be replaced by alpha 1 to plus alpha 1 to delta z minus alpha 0 to delta z CA bar n plus CA bar n minus 1. Am I correct? Yes. Minus beta delta z square. Anything wrong here? Anything wrong? Yes or no? Everything is correct? Anything wrong here? What is that? Something is wrong. CA bar n plus 1 is here. What is that? What is substituted by alpha 1 to delta z?
2 times CA bar n minus 1.
Or 2 times CA bar n.
N minus 1. N minus 1. 2 times of CA bar n minus
2 times of CA bar n minus 1, yes.
1. And CA bar n bar n 4 by 3.
Is that correct?
CA
Yes or no?
is correct. And CA bar n bar delta z square CA bar power.
You want to take common, right?
Yes, sir. Beta delta z.
Is this wrong or right?
Correct.
Yeah, that's what I'm saying. You have to manipulate further.
Last term has the power n.
You said right. You should not say right. If you say wrong, it is wrong. Because I accept because I never got 100 out of 100 in mathematics, but I know a lot of silly mistakes. If you say wrong, I will be very happy. If you say right, I will be unhappy. If you try to find something wrong, I will be very, very happy. That's what I want. This is correct so far? How to reduce further? If you look at CA bar n in common minus 2, then we can put minus here, 2 plus alpha 0. Is it correct? 2 CA bar n minus 1 plus alpha 1 2 delta z minus beta delta z square CA bar n to the power n equals to 0. Is that correct? Check it out. Yes? Jacobian. What is my Jacobian? Dou R1 by dou CA bar 1. Dou R1 by dou CA bar 1 equals to dou R1 by dou CA bar 1 equals to if I take dou R1 by dou CA bar 1 equals to what I will get? 1. Dou R1 by dou CA bar 2 0 will go to 0. Dou R2 by dou CA bar 1 dou R2 by dou CA bar 2 minus 2 minus beta delta z square into CA bar old. If you don't put old, it's a mistake. CA bar old of 2. What is that? What is that? What are you saying? Into? Don't say something extra. Everything is correct? And then CA bar dou R2 by dou CA bar 3 equals to 1 again. And then rest of the part is it. Then dou R3 by dou CA bar 1 equals to 0. Right? Dou R3 by dou CA bar 2 equals to 1. And this same thing will be repeated here. What is that? Minus 2 minus beta delta z square in CA bar old 3 to the power n minus 1, 1 and 0. So if you look at, you get some kind of banded algorithm, and finally you get at the nth residual, you get what? CA bar n is there, which is minus 2 or plus 2. This plus minus 2, I think, right? Minus 2 alpha 0 delta z, and then minus beta delta z square in CA bar of n to the power n minus 1. Right? Previous term will be what? 2. That's all. Everything else is 0. Everything else is 0. This is cross function of Jacobian. And then you can solve it. So once a residual Jacobian actually are formed, you can actually solve, and then you can put in the computer. So the exam I will give a problem of differential equation. I will ask you to construct residual and Jacobian and write the algorithm how to solve. So next class onwards, what I will do, I will try to start the time dependent problem. So for you have the ordinary differential equation. Next we will be talking about the time dependent differential equation like initial order problem and the partial differential equation. So next class will be the 2 classes we are dealing with, so that will be the time dependent problem. Thanks for your attention.